Now on to Module 12, the cerebral cortex. Cerebral cortex is a thin layer of neural cells covering the cerebral hemispheres. It's the body's ultimate control and information processing center. They're protected by glial cells called the glia, which support, nourish, and protect the neurons. The glia are also involved in learning and thinking, since they help the neurons to connect. The brain has left and right hemispheres, and they're consisted of frontal lobe, parietal lobes, temporal lobe, and occipital lobe. And the cerebral cortex, they have 4 lobes. The frontal lobes in the front, and they are right behind the forehead. They're involved in speaking and muscle movement. They have the motor cortex, which regulates movement. Somebody called Jose Delgado, he's a Spanish scientist. He stimulated the left motor cortex to induce movement in the right hand, making a fist. Now, some parts have more areas of the cortex dedicated to them. For instance, your fingers need very accurate movement, so it has greater representation. It's also involved in making plans and judgments. And the parietal lobes is in the back and above the occipital lobe. It receives sensory input for touch and body position. It has the somatosensory cortex, the more sensitive the body region. There's more of this cortex dedicated to that part. For instance, lips are the most sensitive. So a larger area of the cortex is dedicated to the lips. The temporal lobes are roughly above the ears, and they receive auditory inputs, and right side receives left ear input, and vice versa. They have the auditory cortex. The occipital lobes are at the back of the head, and they receive visual input and has the visual cortex. They're called the phantom arms or phantom hearing, right? And they are related to activities in the relevant cortexes, even when you don't have an arm or hearing. Really interesting, isn't it? You can feel your arm even if you don't have it. Now, the input to the somatosensory cortex can be something like this. And the output, which is the motor cortex, can be something like that in the left hemisphere section, which controls the body's right side. So they have pretty similar and also pretty different functions, right? So the brain divides up the work, dividing and conquering. It also happens within our brains. Now, let's look at the interfaces of the brain-computer. So things that connect the brain to a computer. It's possible to allow inputs into computers, robots, using just a brain, right? Therefore, it can be used to help the disabled, the paralyzed, or amputated with robot arms, aka cognitive neural prosthetics. The association areas are the areas of the cerebral cortex that are not involved in primary motor or sensory functions. Rather, they are involved in higher mental functions like remembering, learning, thinking, and speaking. So no observable response to electrical stimulus are there. We only use 10% of our brains. That is false because much of our brains are the association areas, which we all use, but not at 100% all of the time. Which is why, when the 90% areas are damaged, we become brain dead. So you might think that, oh, we only use 10% of our brains anyway. It might try to lesion out the 90%, which is the rest of your brain, out of your head. And I don't really recommend that choice because you might be brain dead. Now, the prefrontal cortex is an association area near the frontal cortex. It enables judgment, planning, and processing of new memories. Example is somebody called Phineas Gage, a railroad worker. You might want to remember this man's name because it comes out a lot on the test. So a metal rod went through his prefrontal cortex, which is the decision making and also related to your personality part of your brain. Now, the damage in the prefrontal cortex led to a change in personality. So Phineas Gage became really kind of violent and aggressive towards people, and he became more irritable and dishonest. So you can see that the prefrontal cortex, they really have a high kind of responsibility about your personality, right? Because a damage to it really changed up a man's kind of personality and who he is. And the association area near the parietal lobes, Einstein had a very large and unusually shaped one. It enables mathematical and spatial reasoning. So Einstein having a really large parietal lobe, it may have led to his kind of genius math skills. The stimulation can also result in the desire to move something. And the association area under the right temporal lobe, they enable us to recognize faces. The brain is complex, and memory, language, attention, they all result from synchronized activity among many parts. And we're going to talk about brain's plasticity now. Plasticity, this is a really important vocab as well, as the brain's ability to change, especially during childhood, by reorganizing after damage or by building new pathways based on experience. Now, explaining brain damage. Severed neurons, they don't regenerate, sadly. Now, some functions are tied to some areas, so temporal lobe damage, it may lead to permanent inability to recognize faces. However, the brain can somewhat reorganize in response to damage. The constraint in this therapy, it helps this process by attempting to rewire brains and improve dexterity of a brain damaged child or adult stroke victims. The good limb is constrained, and they are forced to use the bad limb, and this can lead to brain rewiring and therefore recovery of the limb usage. Also, if you're blind or deaf, your brain uses the parts originally destined for sight or hearing to different uses. For example, a blind person can read through a braille, and parts of the visual cortex are invaded by the parts of the brain that is related to sense of touch. And for another example, a deaf person has better peripheral vision because more neurons in brain area can be used to process visual information instead of hearing. And neurogenesis is the formation of new neurons. Sometimes the brain also creates new neurons to repair itself, and the master stem cells can develop into any brain cells, so the stem cell research can help in this area. Now on to Module 13, we're almost there guys, please bear with me. Now the brain hemisphere organization and the biology of consciousness. Our divided brain. Our right brain controls and receives sensory input from the left side and vice versa. Splitting the brain. The corpus callosum is a band of neural fibers that connect the left and right hemispheres and carries messages or signals between them. Now cutting the corpus callosum by some other way, isolating the brain can result in a split brain. Sometimes the corpus callosum is cut to prevent epileptic seizures. We want to remember this because this comes out in the test a lot as well. This was an experiment by Sperry and Gazzaniga. Now testing the divided brain. When an experimenter flashes the word HEART, heart, across the visual field, a woman with a split brain reports seeing the portion of the word transmitted to her left hemisphere. However, if asked to indicate with her left hand what she saw, she points to the portion of the word transmitted to her right hemisphere. So, Gazzaniga, this man said, look at the dot, and the woman said, yeah. And the two words are separated by dot are momentarily projected. So this Gazzaniga guy asks this split brain woman, what word did you see? And the woman says art. As you can see from the image, art was from her left hemisphere, right? So when the woman, on the other hand, is asked to point with your left hand to the word you saw, she points at HE. So her hand-eye coordination is impossible because she has a split brain and information cannot be kind of transferred across her brain and between her fingers. So with her fingers, she kind of points to HE, but when asked to kind of describe what word did she see, she says arts. So since the left side governs speech because it has the Broca's area, When asked to say what they saw, they said art. But since right side does more non-verbal things, when asked to point towards their left hand what she saw, they pointed at HE. Now, fun fact about split brains is that they can draw different shapes with each hand at the same time. That's pretty cool, isn't it? Right-left differences in the intact brain is about how the left side is about language, logic speaking, writing, reading, reasoning, or understanding. And the right part is responsible for inferences, modulating speech, making it clearer, and orchestrating our self-sense. And the consciousness is about how our awareness of ourselves and our environment is going to impact us. And the cognitive neuroscience is the study of the brain activity linked with mental processes such as perception, thinking, memory, and language. They use functional fMRIs to map brain activity. And dual processing is about how the mind has two tracks, which is why we have dual processing. The principle that information is often simultaneously processed on separate conscious and unconscious tracks. Now, the conscious track are things we are aware of. The unconscious track are things we know but aren't actually aware of. Examples that show this are blind sight, so no conscious sight, but we still see unconsciously. The information just never reaches conscious. So we can't see, but still our actions reflect the fact that we can see, so we know where objects are or what they look like. Or a person blind on the left eye cannot see the faces on that side but can still sense emotion. The hollow face illusion is an inverted mask that looks like it's protruding, conscious interpretation, but your mind knows that it's really inverted, unconscious. So when you see a speck of dust on it, your finger automatically reaches into the mask. The hollow face illusion is we tend to see an illusory protruding face even on an inverted mask, right? Yet, research participants will accurately reach for a speck on the face inside the inverted mask, suggesting that our unconscious mind seems to know the truth of the illusion. So when you decide to move your hands, your unconsciousness may decide before you are consciously aware of it, like when you have to tap something regularly, like every time a clock cycles through. So why does 2-track running on automatic pilot mode allows your consciousness to monitor new and important things, right? Instead of being focused on the smaller things. So this kind of increases your work productivity.